you guys hang on to this. If you lose it, I've got more of them, but if you do lose it and you don't have it with you at home, it's on this page of notes and it's also on the front of the homework packet. But this is really just because people aren't always super familiar with all these numbers, and these are really helpful when you're breaking down radicals so you can look at them. So the way that I have this laid out here is, and it's kind of here real quick just to show you, this would be the root of the number as the column goes from left to right. So the whole first column after that, the second column on the paper, these are all perfect squares up to 12, perfect cubes up to 12, perfect fourths, perfect fifths. We could keep generating lists, but usually these are the numbers that you want to be familiar with. And honestly, if I'm being totally honest with you, you're not probably going to see, like these numbers, I just did it to fill out the little spreadsheet there that you got in front. You're not probably going to see most of the numbers that are kind of below that little line I just drew, and maybe just a couple of those bigger numbers like the 40, 96. You might see them, but typically you're going to work with the smaller numbers in these categories to break down radicals. But in general, just to give you some little vocab here, so this is just a picture of a square root, or it's just a root in general, sorry, an nth root. So whatever root you're working with is the number that's out in front here. If you have a square root, like this is just implied that there would be a little 2 here. They don't write the index, or what they call the index, for a square root. So if you just see a radical symbol with no number, that's assumed to be a square root. Otherwise, if it has a number, that's called the index of the root. The actual kind of like check mark looking sign is the radical sign. And then what is underneath the square root, cube root, fourth root, whatever you're working with, that's called the radicand. All right, so whatever's under the radical is called the radicand. Now, in general, we're probably in a situation where you guys have definitely simplified square roots, but probably not like maybe a third or fourth or fifth. So we're going to get into that this week. But anyway, to the side here, what I just wrote down, just kind of in general, a little example with the powers of 5 here. So this says 5 squared is 25. So it says 5 is the square root of 25. So that means if I take the square root of 25, it equals 5. This one says 5 to the third power is 125. So I'm just going to write this down here. It means if I take the cube root of 125, it's going to be equal to 5. And then on down, it says 5 to the fourth is 625. So if you took the fourth root of 625, it'd give you 5. Fifth root of 3125 would be 5. So just in general, if you have something to a power and it's equal to a number, if I take the nth root of the other side of the equation, it should be equal to whatever I was taking to that exponent. So if you want a little example with numbers there, just kind of like just what I wrote down there. If I have 5 to the third equals 125, then 5 is going to be equal to the cube root of 125. That would just be that same definition, but with a number plugged into it. Okay, everything we're going to work with today will be perfect. So all the radicals will cancel out today just to kind of get you used to this. But I do want to make a little bit of a point before we actually start doing any of these questions down at the bottom. Now, if you have an even root, so I mean like a square root, a fourth root, a sixth root, and you're going to take that root of a positive number. I'm just going to make up a little example. Let's say I did the square root of 64. What would you tell me that would be? 8. Okay, done. All right, no plus or minus, nothing like that, because I already had the radical written in the problem. Okay, so I wrote radical 64, so the answer is just 8. Okay, what if I said the square root of negative 64? It would be an I. Okay, so just for this unit, we're only going to ask you, you'll see this in the directions, if it has a real root. So this would be 8I. If you put that on a quiz or test, I wouldn't count you off or anything. But this, what I want to do here is that it has no real root. It would have to be imaginary. So you cannot take the even root of a negative number and get a real answer. All right, so I'm just going to write that in general. Can't take the even root. So square root, fourth root, sixth root. I doubt you will see a sixth root, but you can't take the even root of a negative number. just in general. It will not be a real solution. It'll be an I if you wrote it down, but we're not going to deal with any imaginary numbers as we go through this unit. So if you would put I, just put no real root. Now, that is different if you have an odd root, which these you guys probably aren't super familiar with. So let's say, and I'm actually going to use 64 again, but I'm going to do the cube root of 64. If I asked you what the cube root of 64 is, does anybody know what it is? 4. All right, now, the reason for that, if you take 4 times 4 times 4, that does equal 64. If you multiply 4 by itself 3 times. Now, this, I'm going to write down the cube root of negative 64. Can you do the third root of negative 64? What would you write down for that one? Yes, you can do this. Okay, now, this does have a solution. You can take the odd root of a negative number. The answer will just be negative. So the deal is here, if I take negative 4 times negative 4, right, that's 2 of them, that'd be positive 16. But because I have an odd number here, I'm doing 3 of them, that reintroduces the negative, and that will be negative 64. So you can take the odd root of a negative. The answer is just going to be negative. It's just that little example right there. So you can't take the even root of a negative number, but you can take the odd root of a negative number and get a real answer. All right, so any of these questions, if it's an even root and you're trying to work with a negative under that root, then you just say no real solution, or no, or I can't do it, or whatever you want to write down. Just don't write me a number. And then if it's odd, you can do that for a negative. So each one of these questions down here, and feel free to look at this lovely little yellow piece of paper. So the first column just tells you what the root is. The second column, square roots. The third one, cube roots. The fourth column, fourth roots, and on down the line. So if you're not familiar with these numbers, that's okay. Just look at that little piece of paper. That's why I made it for you. So what would you tell me for square root of negative 49? No bueno, we can't do this. This is no real root. You would tell me 7i. If you wrote that, I wouldn't count any points off or anything, but it doesn't have a real root. Can I do the second question, which says negative times the square root of 81? What would you write for this one? What do you think? Negative 9. This is okay. So this is literally like negative 1 times the square root of 81. So this is okay. This is negative 9. There's 2 ways you could do the letter C here. So 4 and 25 are both on that list of perfect squares. So square root of 4 is 2, square root of 25 is 5. Multiply them together, you could get 10. The other way you could do that, you can always multiply square roots together. You just squish them together under the same square root. So 4 times 25, this would be the same as the square root of 100, which would also give you 10. Just kind of 2 different ways to do it. Whatever's easier for you is what you should try to do in the question. All right, who can raise your hand and tell me for this last one? I have a fraction for this last one. So it says square root of 36 over 121. Who would you tell me for that? Perfect, okay. 6 over 11. So if it's all under a square root, you can separate it and think about it as like square root of 36 over square root of 121. Both of those are perfect squares. You don't have to think about it all as one number. You can do the top and bottom separately. All right, now, the rest of these, I don't know how familiar you're going to be with these numbers. The squares maybe are okay, but the cubes, the fourths, and the fifths might be numbers you're not super familiar with. So feel free to look at that little lovely yellow paper. Can anybody raise your hand and tell me the cube root of 343? Yes. Positive 7. If you take positive 7 times itself 3 times, you get 343. What about the cube root of negative 125? For sure. If you're doing an odd root of a negative number, the answer should be negative. Okay, the third one, kind of tricky. I have the cube root of negative 1/8. Can I do that one? Yeah. Yes, 1 under any root is just going to be equal to 1. Since this is negative, this would just be negative 1. The cube root of 8 is 2. So this would be negative 1/2. What about the cube root of 27 over 1,000? Yeah. 3/10. Good. Cube root of 27 is 3. Cube root of 1,000 is 10. All right, now I'm going to move on. These are fourth roots. All right, so fourth root. So if you're looking at that little yellow paper, the fourth column. If you're looking up on the board, it's actually the third column. What is the fourth root of 625? 5. Done. Usually if, I don't want to say always, but usually if it ends in a 5, it's going to be 5. So just keep that in mind. What about the fourth root of negative 16 over 10,000? Can I do that? No, this is not good. You cannot take the even root, and I did, these are both perfect fourths if they didn't have the negative on there, but this is not something, like if you tried to type that in your calculator, it would give you an error message because it's going to be an I in the answer, so no real answer for the root there. What about the fourth root of 256 over 625? 4 over 5, done. Okay, what about, now the last one has a negative out in front, not under the radical, so this one's okay. So what about negative 1 times the fourth root of 2401? Negative 7, good. Totally fine if the negative's outside. Okay, now these are all fifth roots, so if I was looking on my yellow paper, I'd look in that fifth column. A lot of these are really big numbers. And then up on the board, it's actually the fourth column. What would you tell me for the fifth root of negative 1? It's got to be negative 1. Yes. Okay. So if you're doing an odd root of a negative number, it has to be, so I'm going to write that, odd root of a negative, it has to be a negative. What about the fifth root of 7,776? 6, done. All right, and then the last one, this is just going to be a fraction. The fifth root of 32 is 2. The fifth root of 243 is 3, so that one would simplify to be 2/3. If you have an odd root of a negative number, the answer will be negative. If you have an odd root of a positive number, the answer will be positive. Okay, let's look at now variables. Okay, so I'm just going to make up a problem here for us to practice to see if you guys know how to do this. Maybe you've done this before, maybe not. Let's say I was taking the cube root of x to the 30th power. I'm just making up a little example. Does anybody know how to simplify an exponent under some kind of a root? Like, what do I do with the 30 and the 3?
You divide.
You divide them. Okay, so this, you can think of, it's the exponent divided by the index of the root. So like the index would be the denominator, the exponent would be the numerator. All the questions today are going to be nice, perfect answers, so we won't worry about when it's not tomorrow. But this would literally just simplify to be x to the 10th, no radical, because 30 is divisible by 3. If you have a cube root, you want your exponent to be divisible by 3 to take anything out as a perfect cube. All right, and then just remember, if you have a radical with no number, like I do here, that's just a square root. So the index of that would be 2. So what would you tell me for square root of x squared? Yeah, just x. Yeah, it's just x. What about the square root of x to the 8? X to the 4th, yeah. Just divide the exponent by 2. Now, if you're going to do a cube root, you're going to divide by 3. So what's the cube root of x to the 3rd? X. Cube root and third root and third power just cancel each other out. It's kind of like that very first one. Square root and squared cancel each other out. What if I did the cube root of x to the 9th? What would that simplify to be? X to the 3rd, done. All right, now, what if I've got a negative exponent, so not a negative number, a negative exponent. I have the 4th root of x to the negative 4th. What would this simplify to be? Anybody know? You're on the right track. He says negative x. This would be negative 4 divided by 4, so it'd be x to the negative 1 power, which, remember, negative exponent does not mean negative number. I'm just going to turn that into a fraction real quick to get rid of that negative exponent. That would just be 1 over x. So if you got a negative exponent, you're just going to end up with a fraction. What about the fourth root of, now this is a fourth root, x to the 8th? 2, x squared, just 8 divided by 4, so x squared. What about fifth root of x to the 10th? That one's also x squared. 5 goes into 10 twice. What would you guys write for the fifth root of x to the negative 40th? 8, right? So this would, okay, you divide that, be x to the negative 8. Just take care of that negative exponent. I'm going to write it as 1 over x to the 8th. That's all you have to do. Is anybody having a question? We're going to work in our next lesson with stuff where it's not perfect. So these are all perfect today. So in this third example, this is just a mixture. This has numbers and it has variables underneath some kind of a radical. So we're just going to go through these real quick and see if you guys can simplify them. All the radicals should cancel out for all the problems today. These are all perfect, whichever question you're working with. So if I do, like for example, I'll just do the first one and then I'll have you guys help me with the rest. So this is square root. So square root of 25 would come out as 5. X to the 24th, you just divide the exponent by the root. So 24 divided by 2 is 12. Same thing for the y. Exponent divided by the root, 8 divided by 4. I'm sorry, 8 divided by 2 is 4. So that would end up being 5x to the 12th, y to the 4th to simplify that. We're just removing any perfect squares. Everything should be perfect today. If I do the second question, just raise your hand and tell me what you do here. This is the fifth root of 32x to the 15th, y to the 20th. What would that simplify to be if I took a fifth root there? Oh, don't everyone volunteer at once. What do we think? Yeah. Perfect. 2x to the third, y to the 4th. What about my third question here? I've got the fourth root of 1296, x to the 16th, y to the 28th. What would that simplify to be? Oh, everyone's so quiet. Do you guys see, like on this lovely list, the 1296 is, let's see, the 6th number down. So this is just going to come out as a 6. For the exponents, you just divide them by 4. So 16 divided by 4, that'll be x to the 4th. 28 divided by 4, that'll be y to the 7th. Totally done. That's all you have to do. If I do the next one, I got square root, right? So square root of 9 is 3. X to the negative 10, this would be x to the negative 5th. If you want to skip this step, go right ahead and just make it into a fraction. This would come out as y to the 6th. Now, to get rid of that negative exponent, we're going to keep the 3y to the 6th where it's at, and the x to the 5th goes to the bottom of that fraction to get rid of the negative exponent. All right, cube root of 216. If you look at your lovely little list here we've got on this piece of paper, 216 is the 6th number down in that third column of cube roots, so this is just a 6. 12 divided by 3 is going to come out a to the 4th, b to the 3rd divided by 3. So 3 divided by 3 would just cancel out, but you'd still have a b there. So it'd be b to the 1st. Typically, you will not see a first power written after something, so just be 6 a to the 4th b. Now, for the next one, here's what I would tell you. If you have, any, like in parentheses or in this case under a radical, simplify first and then take the root when you're done. It makes the problem way easier to work with. So if I'm looking at this problem, I'm just going to ignore that fourth root for a second. So 81 x to the 16th over x to the 36, just using our exponent properties. I'm going to leave that 81 on the top. There's nothing to simplify that with. But for the x's, you got 16 on the top, 36 on the bottom. So I'd be like, okay, I got 20 more x's on the bottom. So I'm just literally reducing that fraction using exponent properties. I did not take a fourth root. So I need to go back and do that. So I'm just going to take fourth root of the top, fourth root of the bottom, fourth root of 81. If you look at this fourth column, 81 is the 3rd number down. So that means the fourth root of 81 is 3. For the variable, just divide your exponent by the root. So this would just end up being x to the 5th. Okay, now negative under an odd root, totally fine. So cube root of negative 27, just negative 3. Do not create a fraction here. You don't have a negative exponent. It's just a negative number. That's cool to stay where it's at. All right, cube root c to the 6. 6 divided by 3 is going to give you 2. So it should be negative 3c to the 2nd. All right, the next guy, I'm just going to go ahead and make it into a fraction from the jump because that negative exponent's going to need to go to the bottom. So cube root negative, or sorry, not cube root, fifth root. If you look at this lovely list on the fifth roots, that 3125 is the fifth one down. Usually, I don't want to say always, but usually if it ends in a 5, 5 will be the root there. And then a to the 50th would be a to the 10th. I'm going to leave that on the top. And b to the negative 45 would be b to the negative 9th. So I'm just going to put b to the positive 9 on the bottom of the fraction to take care of that. And then I'll just do one more real quick, and then we'll just do a little bit different example at the very bottom. Okay, now, if you have any kind of a complicated mess like this underneath a root, simplify what you have first. It usually makes the problem way easier to do. So 2 over 128, if you just reduce that, both of those guys are divisible by 2, that'd be 1 over 64. Okay, as I write this, I'm just going to put a 64 in the bottom. I'll put the 1 in the top if everything else canceled out of the top, but I'm just going to put the 64 in the bottom for a second. All right, now if I look at my x's, 10 on the top, 16 on the bottom, so you got 6 more on the bottom. And if I look at my y's, 17 on the top, 5 on the bottom, so I've got 12 more on the top. Now what I got to remember, I did not take the fourth root here. I just simplified what was underneath there, so I still need to go back and do that. Or sorry, this is a cube root, my fault. So cube root, top and bottom. Okay, now make sure you're paying attention. The numbers like 16, 64, 81, they're on a couple of the lists, so make sure you're paying attention to what type of root you're taking. The top of this is just going to be y to the 4th. The cube root of 64 is going to be 4. Don't put an 8 there because this is a cube root. And then 6 divided by 3, the bottom of that would be x squared. Is anybody having a question? Okay, we're just going to do one quick example. We'll do more with some radical equations as we get later in this unit. This is just a super basic version. So I just want to see if you guys remember this kind of from Algebra 1. So if I just have x squared equals 100, how do I solve that equation? Like, what would you do? X squared equals 100. Square root, right? All right, so I am introducing a square root into the problem. That didn't already exist there, right? I'm introducing that. So if I introduce a square root into the problem, how's that going to affect my answer? Like, what do I have to remember? Plus or minus. All right, so plus or minus 10. There's 2 numbers you can plug in to make, if I do 10 squared, perfect, that's 100. If you do negative 10 though, negative 10 squared, negative 10 times negative 10, that is also 100, so that has 2 answers. Okay, how would I solve x to the 3rd equals negative 27? Like, what would you do to both sides there to get rid of the 3rd power? Cube root. Okay, now, this is cube root, right? We saw this above. The cube root of x to the 3rd, the cube root, the power and the root cancel each other out, so this is just x. What would I write as my answer here? Do I need a plus and minus? No. Okay, so there's only one answer to that question. If you plugged in positive 3 to the 3rd power, that'd give you positive 27. So that would give you back. If you have an odd root, do not put a plus or minus. If you do have an even root, you got to put a plus and minus. All right, so maybe I should write that. If you have an even root that you're taking to both sides, plus minus. If you do an odd root, don't put a plus and minus. There's only one answer. This question has 2 answers. This answer has, or this equation has 1 answer. All right, if I do, like, so now this is even, right? So if I do a 4th root, I got to remember to put a plus and minus because there's actually 2 answers that'll work here. When you do, if you plug your answer in with that 4th power, if it's negative, that 4th power will cancel out the negative. If you have an even number of negatives, they all cancel out. So this has 2 answers. 4th root of 1 is 1. 4th root of 16 is 2. So this has 2 answers. It could be a half or negative a half. And then this last one, this is like the 3rd root. If I do a 5th root, there's only 1 answer here. And the 5th root of 32 is 2. If you plugged in negative 2, it would actually spit out negative 32 if you took that to the 5th power. So it only has 1 answer for an odd root, 2 answers for an even root. Is anybody having a question?